2 minutes, yeah.
Without deadlines, life would be even worse.
Oh, deadlines. There. You have to get close. Especially for perfectionists. It's not ready. Keep working. It's not ready. Keep working.
See, there's this line, the perfect is the enemy of the good.
Yeah.
And deadlines enable us to follow that rule. Otherwise, we will not. Because I know one person for whom this is not true, which is well calm. He's an example of the life is the opposite of this, right?
So it's a pleasure to introduce Rob Rutenbar, who's the head of the computer science department at the University of Illinois at Urbana-Champaign. So I'm going to tell you all the reasons that Rob is famous as an electrical engineer, which will have nothing to do with his talk today, as you can see. But I want to tell you about this anyway. So he got his PhD from Michigan in '84, spent 25 years at Carnegie Mellon, and then went to become the chair at Illinois in 2010. So his work has been on custom tools for ICs, and he's won a whole bunch of prizes. He's a fellow of the IEEE, fellow of the ACM, won the IEEE Circuits and Systems Industrial Pioneer Award. But the thing that brought him here today is the discussion of curriculum. And a few years ago, he led this big effort at Illinois to introduce a new curriculum called CS+X. And that's something we've been talking about here independently at Berkeley, and he's made it a big success at Illinois. And maybe he'll tell you this story, but if not, I will. They tried it at Stanford and they got it wrong and it didn't work. So there are different ways to do this, and so we'd like to understand why he did it so well. And so I will let you take over.
Thanks so much. Well, thank you so much for the invitation. And the opportunity to come here. The approximate cause is that Jim and I were both at the CRA Snowbird meeting over the summer, and I gave the synopsis abstract version of this talk, which went really, really well. And I said, I should come do this at Berkeley. And Jim said, you should come do this at Berkeley. And because of the way our schedules work, 8 months later, we were able to make this go. So thank you so much. I want to talk about this notion of taking this interesting stuff that we do somewhere at the intersection of computing and data and trying to take this stuff wide across the curriculum, across the institution, and do something that has some impact. So let's start with the standard acknowledgement that yes, certainly in the computer science universe, they're coming in the front door. So everybody has their own favorite hockey stick curve. This is my hockey stick curve. So, oops. Oh, okay. So at Illinois, you apply to the college. Computer science is a department by itself, not associated with EE in the College of Engineering. You apply to the college, and then you tell us what you want to major in. Okay, so this is a curve. The horizontal axis is year. The vertical axis is what fraction of people want to be the name associated with every one of those majors. And so there are 10 things you can major in, aerospace engineering and nuclear and all this other kinds of stuff. Those of you who are in the emerging field of data science might notice something the experts call a pattern, right, on this graph, okay? Everybody wants to be computer science, right? We are sort of crushing this. Every other department head in the College of Engineering hates this curve, but one. And it's also actually very asymmetric. It's not, as has been sometimes suggested, people just want to study something that has the word computer in it. There are 3 times, nearly 4 times as many people applying to computer science as computer engineering, right? So we're just dominant in this case. Now, the fact is that this creates some interesting stresses for those of us who are actually trying to deliver curricula. So there are a variety of classical institutional responses, right, to this. I thought I would summarize them, for you. So the first one, and we've all heard it, is, oh, this is like that bubble thing. You fooled me once, right? Not going to happen again. No, and it's going to go away, okay? And then when it stops going away, right, the next one we get is, oh, well, here's some TAs, right? And then when that doesn't help, it's like, okay, maybe if you're lucky, you get a few more faculty lines. And where we are for institutional response today is just, uh-oh, right? Just, cosmic uh-oh. It looks like we're going to have to do something different. And, here's our macroscopic numbers. The hockey stick on just how many majors we've got is gigantic. We at Illinois are headed toward 2,000 if we basically don't do anything differently. You guys are already around 2,400 or something like that. So we're also going to be very large. The other thing that's interesting and worth measuring is how much teaching you're doing. So the bar chart on the right, you can think of this as proportional to class seats. This is actually instructional units. So if 100 people are in a class that's 3 units, that's 300 instructional units delivered, and that's what that's actually measuring. And so math is the largest provider of teaching seats on the campus, and computer science is now number 2. Right? And what's interesting is we're bigger than physics, we're bigger than chemistry, we're bigger than economics, we're bigger than psychology, we're bigger than all these things, and we're bigger than electrical and computer engineering, which is still at the moment a larger department. And one of the reasons we're bigger is that we also teach a very large number of units to people who are not us, right? Which is not true for pretty much everybody else in engineering. So half of those are taken by computer science majors, about a quarter of them are the rest of the College of Engineering, and a quarter of them are everybody else. So said differently, about half of our teaching is outward facing. It's people who's not us, who are not our majors, and that's growing. I'm going to show you some pie charts about that. And that wave of demand creates some other interesting side effects, and again, a curve that is not real popular when I show it to the rest of the College of Engineering. If you take the number of instructional units you offer and you divide by the number of tenure track faculty, you can get a measure of teaching intensity. And we are also the number 1 unit in the College of Engineering, bigger than physics, which is a department in engineering. Which is very interesting. So we are teaching at a larger level of intensity for tenure track faculty than the physicists, who are awfully good at teaching people who don't want to be physicists. Okay? Many people who against their will are taking some of those classes. So the computer science faculty are teaching at maximum intensity. So this is all, it's good to be popular, right? But it creates some interesting challenges. So I think the first response that most departments have is to do what I'm saying is to go deep, right? And going deep means you add teaching staff, instructional faculty, you add TAs, you try to figure out what you're allowed to do in terms of taking undergraduates and making them graders or lab assistants or things that are almost but not quite teaching assistants. You double down on classes, you double down on seats in classes and sections of classes, offering them at uncomfortable times like 8 o'clock in the morning, right, or at night or on the weekends. I am told that you have some special accommodations with the fire marshal to actually allow you guys to teach at the scale. I'm about to invite the fire marshal's team over to dinner. Apparently that's my next step. More faculty, if you can actually convince people all the way up to the top of the food chain that this is a good thing. And one of the other things that starts happening, and you guys are in the middle of this effort, University of Illinois is in the middle of this effort, you also start looking at where you are in terms of the org chart. So whether the structure you have, are you at the right depth in the org chart, right? And so that goes into what I'm calling some new deep vocabulary. Decanal is an adjective that none of us knew, 2 years ago, right? Etymology would be Latin decanus, right? Frequency and current use, almost never. I enjoy that one. Almost never. Of or pertaining to a dean or deanery. I like the 1862 definition, the specially decanal virtues. I believe that we can say that data science is an emerging discipline that has specially decanal virtues. Okay, and that's just not a sentence that was coming out of anybody's mouth about a couple of years ago. So, you guys are in the middle of this. My guys are in the middle of this. We're totally not going to go there. I think that going deep is necessary but not sufficient. And what the bulk of this talk is about is trying to go wide instead. And I love this photo. This is a photo of Steve Jobs on the introduction of the iPad. right, standing in front of this big sign, the intersection of technology and liberal arts. It's technology married with liberal arts, married with humanities that yields the results that make our hearts sing. So this is the notion that there is stuff involved in trying to take the stuff that we love, right, the computing technologies, the data-oriented and data science-oriented technologies, and to connect them with people who don't necessarily look like us. And so there's an argument that a really good response is to try to take the computing and data enterprise and connect it widely across campus. And I've shown this slide for almost a decade now. It's, for us to become a hub for, the data-enriched sciences, the professional endeavors like, business and law and health and medicine that are being disrupted by data. It's very interesting to go talk to people who do digital humanities. For a living, it's historically been the case that people in the humanities often have to obtain monies to get travel grants to go find the artifacts or the objects that they want to study, and now suddenly somebody else got there first, digitized them, they're all online, and the question is, people are seeing data at volumes that they've never seen in their entire careers, available over the weekend. They need a different set of skills to be able to prosper in that environment. Folks in art and design, social sciences, other social kinds of opportunities. There's a really interesting opportunity to try to take computing and data out of its STEM niche and connect it widely. Right, so this is the sort of the background for this set of degrees that we've been calling CS+X, and I'm going to talk a little bit about the coinage in a little bit, at Illinois. So the very, very high level, the one-slide version, they are not a minor in CS or an X. Right? So it's not as though you're in one department and you take a handful, typically 5 or 6 classes in the other side. They are not a dual degree where it's all of the CS degree and all of the X degree. Nobody can afford that, typically. Nobody wants to be around for 6 or 7 years to do that. They are literally half of the CS degree, and I'm going to show you which half of the X degree, offered as a bachelor's degree in the Department of X, owned and operated by the Department of X. That turns out to be highly desirable because it means that the departments that are the X's have a very strong sense of ownership, right, of these degrees. There are components of the financial model that are attractive for this, and it makes us a helpful and useful and positive partner in this engagement. So, literally, it's half of the CS degree, half of the X degree. Now, if you're going to be really fussy about it, the degree is typically 40% computer science, 40% X, and 20% the general education requirements didn't change for anybody to get a bachelor's degree on campus. So we all still have to take English, and we all still have to take some history, and we all still have to take, maybe a science class or something outside of our discipline. But, to first order, half us, half them. And one of the other decisions that we made, and I'm going to talk about why we made it and why it was critical, is that it is the same CS core for all of the X's. And that's primarily an operational decision about making this thing a reality. There are lots of interesting reasons to talk about why you would do this, and I generally like to show that there's a sort of a dichotomy of reasons. There are positive reasons, right? There are reasons. This is the cover of Economist that I like. The data and the availability of ubiquitous computation at all sorts of scales is just disrupting and changing lots of disciplines. There are lots of positive and interesting opportunities, and there are lots of X-oriented disciplines that get that data is a wonderful and cool thing, and they need a partner, and they would like to play with us. There are other disciplines that are in dire straits, right? So if you look at the enrollment curves for computer science, they are convex up with an appropriate exponent. If you look at the enrollment curves for your English department, they are convex down with the same exponent, okay? And there are, so I like this article, The Morbid Fascination with the Death of the Humanities. It's been predicted for a lot of time, but a lot of these folks are, do I have to stay? A lot of these folks, and there they just died, that's terrible. A lot of these folks are in disciplines that are in dreadful shape in terms of the sort of the perception of the public as to the merits of the degree, the vitality and economic reasonableness of the ability to get a job when you're done, right? And a lot of these folks are looking to the rise of digital humanities as a way to lure people back into the discipline, as a way to become more viable and more vibrant, as a way to give people some skills for a broad and uncertain jobs universe as you go forward. So you can decide which side of the graph you think is the most compelling, and honestly it kind of depends on the X, but we see both of these things all the time when we talk to people. Now, I have to give some credit for the coinage. This is Alfred Spector. He was a professor at Carnegie Mellon for a really long time, right? So he's one of the people who did AFS, the file system, and left and started a company that became Transarc that took that stuff proprietary, and then got bought by IBM and was a VP at IBM for a long time, and then ended up the VP of research at Google, so he was funding lots of us in this space. He's now actually managing a hedge fund in New York. I interviewed with him at CMU in 1984, which he actually remembers to his great credit. He coined CS+X around, he says around 2004, 2005, and started talking about it. He started publishing it a half a dozen years later, I guess whatever, 8 years later. He published this sort of widely cited blog post in Xconomy, CS+X for all X. The argument being exactly the stuff that I talked about. CS is increasingly going to be looked to as a hub sort of a discipline. If you know something about CS, can we connect you to a variety of other disciplines and enhance the opportunities to do interesting things in X? As it turned out, our effort at the University of Illinois was already 2 years in flight when I learned about that somebody else had CS+X and had a better claim on this. And in a completely unrelated venture, after I read this article in January 2012, I bought all the CS+X domain names. All of them, really, all of them. And if you were to click on any of them, this is where you would go. Right? You would go to the CS+X at Illinois page, which talks about the degree programs. Now, I have to acknowledge that we are not the only ones in this game, right? So our friends at Stanford are also in this game. And there are a lot of interesting X's there. Most of their X's are in humanities, right? And I think that's a design decision. They've just decided not to have them in STEM or in some other fields. If you ask me a question about this, I'll tell you what I think.
Please tell us what you think.
Hold that thought. I will point at you. I will go like this. Okay. And you will ask me that question. There is a point at which it's important to ask that question because I need to show you a little bit of context. Okay? There is a wide perception that I think these are not as successful as Stanford would like them to be. I think that's fair. I think we're doing better. I'll talk a little bit about it. So, the CS+X portfolio at Illinois looks like this. We have had legacy degrees that are decades old for a very long time. Just like you, we have effectively computer science degrees in the College of Liberal Arts and Sciences. Now, in our case, they are kind of CS+X degrees. They are half CS and half math. That's the big one, the old one, the original one. That's how we started as a computer science department, was that thing. And then we became our own department, and then we got moved into the College of Engineering, and off we go. And this stuck around. And a little bit later, the statistics degree was put together, and that's a smaller thing. Right, but those things are decades old, but they are, in some sense, a template for a way of doing this. And when I got to Illinois in 2010, our faculty said, we really think that there is an opportunity to take this kind of idea and go much broader. Why did we just limit it to these two departments? Couldn't we do this more broadly? And I said, yeah, if you want to do this, I know exactly how you do. Operationally, I know how you do this. Let's take a shot at this, and we took a run at this, and we ended up recruiting these first four partners: anthropology, astronomy, chemistry, and linguistics. These are all departments, again, in the College of Liberal Arts and Sciences, but a little more broad. We have some humanities kinds of stuff here, some social science stuff, some STEM kinds of things, and some things that are kind of on the boundary. The design for this started in 2010. It took 3 years and 3 months to get through the approvals process because we are a large public institution with committees. Enough said. Okay. So we admitted the first class in 2014, so we don't even have the whole pipeline filled up yet. Right. Next year we will admit the class of 2018 and 17, and we'll actually have people all the way through the pipeline. Because everyone has been so incredibly nice to me, I'm not actually going to explain this slide in detail. This is the regulatory matrix, right, for getting a degree through all of the various steps. There is a terrifying number of words and stars and check marks, right, on this.
We can outdo you on this.
Oh.
Certainly we can match you and raise some.
Don't bet me on things that you don't want to lose on. Okay. Look, The departments have to sort of push this thing forward. The colleges have to push this thing forward. The provost office has to get in the loop. There's a special committee filled with people who find joy in reviewing things like this at the campus level. That's all I'm going to say about those people. There is a vote of the faculty senate. This goes to the board of trustees of the University of Illinois, and then this goes to a governmental level agency called the Illinois Board of Higher Education.
We don't do that. There you go.
Told ya.
Our Senate has multiple committees. That's right. So the Senate does more committees, but we don't have that last thing.
Yeah. So, right. So, it took a long time. One of the things I will note is that it took a long time in some sense because this was the first time any of us had ever tried anything like this. And so there was a certain amount of discovery process. And I think we're actually much better at this now. We can actually get this through in about a year and a half. Now, this is a famous book from about 15 years ago. All I really need to know, I learned in kindergarten. In terms of the design principles for CS, all I really need to know, I learned doing a bunch of startup companies. Right? So, what are the things that I think were valuable from my personal startup experiences? The first is that time to market really matters. Right? So we did a lot of stuff to optimize the design to get through the approvals process rapidly and to not spend a gigantic amount of time, like years and years with committees and committees trying to figure curriculum out. I said we need to put this thing together as simply as possible and launch it because of the enormous set of regulatory hurdles that we need to jump through. And as a consequence of that, I kept talking about minimum viable degree. Right? How much does it have to be there for it to make sense pedagogically for all of the X's that we want to do this with? And the architecture that I came up with, that I talked my faculty into, is that it is the same set of CS courses for all the X's. Now, there was a bunch of pushback, very reasonably so, that said, don't you think the anthropologist should get one kind of a curriculum and the astronomer should get another kind of curriculum? And I said, in an ideal universe, at the limit of t goes to infinity, okay, sure, but we are having enough trouble teaching our existing classes against this exponential hockey stick ramp of demand. I don't believe we're going to build a whole bunch of new classes for all of the X's, and I think it is much to our benefit to build out degrees across as many X's as quickly as we can to build momentum, to build visibility, to build support and strength and allies across the campus. So why don't we go into this process with stuff we've already got on our books? And I managed to talk my faculty into doing that, recognizing that this is not a perfect solution.
So, but there are two ways to do this. One is that it could be 3 out of 5, or it is exactly the same 3.
Hold that thought.
Which version did you choose?
I'm going to show you exactly what the courses are. The answer is this 10. Also, everything you know about like pitching a venture capitalist, I've done this a bunch of times. It's like, there's a 15-minute pitch, it's tight, value proposition, team, why us, why now, what's the kind of competitive landscape like, what's the business model, how will we all make money, why is this good, what are the outcomes, why should you do this? We built the curriculum, we built the pitch, we pitched my dean of engineering, we talked about what budget models would work, we came up with an interesting budget model, I'm going to tell you what that is. We pitched some friends in intermediate levels of the College of Liberal Arts and Sciences. They said, this is great. We can take this to the leadership. We took it to the dean and the associate deans in the leadership team, and they literally said, where have you been all of our lives? We have wanted to do stuff like this. We never thought engineering would actually ever want to partner with us. And we said, wow. We just were wondering if you'd like to do this. And they said, we would love to do this. And everything you know from startups about your first product, which is kind of scruffy and doesn't really work, you need early adopter partners that really understand that it won't work and it's a little bit screwed up and it's okay as long as you're honest about that and you're willing to pivot and try to fix things. You need to find partner X's that really want to be a CS+X, and you need to find some faculty inside that really want to be helpful in trying to figure out the student stuff and the curriculum stuff and things like that. So, for example, when we did the pitch to the dean, who's great and has moved on to be the provost at Utah now, the associate dean for social science was a computational anthropologist. right? And the person on campus who is the most noted for doing outward-facing data science, big data education, it's like, so you got data and you want to deal with it, is an astronomer, right? We got those people in the camp. And the other thing you need is a business model, because in universities these days, unless you can find a way to sort of tie this to some revenue-generating opportunity, they're probably not going to let you do it. So CS+X is like an engineering degree. And at the University of Illinois, engineering degrees, like most professional degrees, have something called a tuition differential. It is more expensive to be an engineer, to be a lawyer, to be a business major, actually even I think to be in the ag school, than it is to be a history major or an English major. How much more expensive? $5,000 more expensive, a lot more expensive. What do we do with the money? We split it. Half of it goes to the college that owns X, half of it goes to the college that owns CS. For engineering, this was fine. This was good enough. For the folks in X, this is like, wow, real money, right? Many of these partners are not in places where there's something that not only draws students to them, but draws students and revenue to them. So this is the model. So far, so good. And this is literally some of my pitch deck, right, from 2010. CS+X, a proposed liberal arts and sciences degree at the intersection of computing and liberal arts and sciences. Synopsis of proposal, a new BS degree in LAS, 3 intellectual components through the business model, mechanics, and then here's all the courses and stuff. So, get ready, you're about to ask your question. Okay. To first order, it is the same CS courses that are in the lower division of the CS degree, right? So it is the intro programming course for majors, right? It's something called Software Programming Studio, which is writing programs well. It's discrete math, which is the intro level. The first time people see sets and equivalence classes and maybe first order logic and dynamic programming and graphs and DAGs and all that good stuff. A probability and statistics class that we created, we pulled out of doing it with the statistics department, and we built our own that's discrete. A data structures class, which also has a little bit of algorithms and a little bit of the first exposure to big O and complexity. Systems programming, which is programming at the OS level, APIs, threads, concurrency, file systems, that kind of stuff. Digital design and architecture, we had historically had a digital design class, aka a Randy Katz class, and an architecture class, aka a Hennessy and Patterson class. We smushed them into one. We make them do that. A programming languages class, no, the world does not completely look like the first language you learn to program in. And the algorithms class. So, one of the big things that I had to work on was getting CS faculty buy-in on this spanning basis. Yes?
Is this quarters?
No. No, this is semesters. So this is a lot of CS. Yeah, so when I said half of your 4-year degree is CS, I was totally not lying, right? And I'm not even counting the math stuff required to get into this stuff, which is a slightly triaged, slightly lighter version of what the CS folks do. I think we whacked the calc in 3D, and I think we may have dialed the linear algebra to a slightly less intense version, but it's mostly that.
You may want to answer this later
Mm-hmm.
now, but I would have expected to see more sort of machine learning kind of stuff and less of computer architecture. If you want to talk about people outside the discipline, that's what they would care about more. It seems too minimum viable.
Minimum viable. Minimum viable. I needed to get the whole CS faculty to sign off on, if they know this much, I am happy if the word computer science appears in their degree title.
The political aspect as well.
So, for example, I had a significant component of the faculty that said, we will be fairly unhappy if none of them knows sort of what happens inside a computer. Now, you can disagree with that, but that's pretty close to a quote, right? That's actually very close to a quote. It took a lot of time to get people to buy into the notion that, look, we have a degree that educates people to be computer scientists. It's called the computer science degree. We have no we have no shortage of people lining up to do that. These are different people. It's okay if they're not deep. It's okay if they are broad, right? You know what they're going to be deep in? X and computing at the boundary of X. So that's the argument. So the philosophy is we get the foundation right across theory, software, and hardware, and then we let them go do X. So to your point, concretely, are you really making the anthropologist take computer architecture? And the answer is yes, I am. And something very interesting happened as a consequence of that. An unexpected response was the leadership in liberal arts was very positive about that. And what they said was, number one, we're so happy you actually came over and decided to talk to us. Because you know what? We didn't think engineering even knew we were here. Right? So this was great for just kind of personal dynamics. And the second thing is, we are so happy that you brought your A game and didn't create some CS Lite, watered down, other kind of curriculum. We're very happy that this is the real deal. And we recognize that we are probably pre-filtering and pre-selecting for a smaller universe of students to come do this than if we had CS Lite. But we think that's okay. We think that that's actually a very positive aspect of this. So this whole, no really, you're going to do the nuts and bolts of the CS curriculum was a positive selling point for people in liberal arts, which we totally didn't expect. Right, you're still holding your thought, right? There's some more of this stuff coming. Let me tell you just a little bit about traction. Like, we've only had this degree program going for 3 years. We're about to be in the fourth year. And what can I tell you? Right, so we are currently 11% of the anthropology department, 25% of the astronomy department, 28% of the linguistics department, and approaching 40% of the statistics department.
Can you say something about the absolute numbers?
Small. Here's the reality of things. This is a big department. This has got like 400 students in it, okay? So this is clearly where the data people are going, and we're going to actually go back and redesign this curriculum in a more serious way, because this one is going to be unique, right? This is where some data science stuff is going to happen. It is not in the nature of some of these core humanities departments to be large, right? So how big is anthropology and astronomy? Like 100 students. Okay, like the whole department, the whole undergrad, it's like around 100 students. So are these large numbers? No. But for a department that's got 100 students to have 25% of them being plus X, some of these departments are only seeing organic growth because of us. Right? It's the only reason they have not seen declines. Right? And that turns out to be a surprisingly powerful kind of a thing. I thought I'd show you some sort of broader stuff in the demand landscape. So what do our courses look like? Right? So the introductory data structures courses is a course called 225. This is enrollment. I think this is across 2016. We, computer science, are the minority player, right, in the data structure space. There's a bunch of CS+X folks. This includes math and stats and all these other guys. The ECE guys are actually a bigger component of this because they're a separate department, and they have, I think they made it a requirement, and that they are at the moment a larger cohort. That's actually probably going to switch over the next couple of years. We will probably be bigger than them. And then it is just in the nature of the demand for the discipline that people go take from far outside our discipline. They take the intro course and they say, this is cool, what's next? And we say, well, actually this is next. And a whole bunch of people are taking that. What is this number? This number is 600 a semester going to 800 a semester, right? What about like the more advanced classes? So we picked 2 classes that have the word data in their title, which tends to be a demand kind of a thing, right? So what does databases look like? What does data mining look like? Well, in this case, we are the go ahead, yeah, please.
Those are both upper division?
Those are both upper division. So this is a 200 level course nominally. Think of this as a sophomore, second semester, freshman, sophomore course. These are courses that start with a 4. You can think of these as junior, senior, first year grad school kind of courses. Yes?
So these were not on your list of 10.
These are not. Right. And so one of the things I was going to mention is this is a required course for CS+X. This is something that if you want to, you can go do it. We don't tell people you can't do more CS. We don't require you to do more CS. We expect people to selectively sample stuff from the top end of the curriculum as is desirable and appropriate for whatever X it is that makes them happy. Right? So these are courses that probably have 200 to 300 people in them. Okay? Majority CS, smaller CS+X, lots of ECE folks, lots of computer engineering, and again, a whole bunch of others that just come in from the side. Now, one of the things that I was, I can try to concretely answer maybe your question about like, so what's different for the Stanford degree? The CS+X degrees are literally about half of my curriculum and about half of the X curriculum. And one of the design criteria is that they're not allowed to have more units than the original X degree started with, right? So they are sort of a one-for-one replacement, and it's a 4-year degree. To first order, the Stanford CS+X's feel like 2/3 of the CS department and 2/3 of the X department. And I have heard from a variety of sources at Stanford that heaviness, that inability to let go of some parts of the CS curriculum and some parts of the X curriculum has been a hindrance because it makes these things feel big. And I think that that's something we got right, was to say a tight, small core, a tight, small core. Yeah.
If you're going to talk about this later, that's cool. But one thing that you mentioned last night is the role that CS+X majors have on non-majors trying to enroll in CS courses that are in high demand.
Yeah.
Is there a place where you're going to talk about that?
I can talk about that. Well, actually, no, I can talk about that here. We give CS+X majors some priority in getting into the courses, but it is not our expectation that it is our expectation that as CS+X gets bigger, we will have a large cohort of people in our lower division courses, but we will not have all of them moving lockstep forward into the advanced courses, that it will filter, right? And people will go wide and will sample. So I mean, there's a small number of lower division courses. There's a very large number of upper division courses, and we expect that they will distribute themselves. We are mindful of the fact that it will probably be the case that courses that have the word data in them and courses that have the word learning in them, possibly courses that have the word software engineering in them, right? Maybe hotspots, and we, like everybody else, may have to do something about that. But we don't expect to have to scale up everything in our upper division to accommodate.
The fact that you have big pies there labeled other makes it seem like you're not over-enrolled if they can get in.
I think so. I mean, we are, for most of these things right now, the hardcore physical constraints are rooms, sections, and not having people teach more than umpteen sections of 200 or 300. We are highly room limited at this point. I mean, it's a giant. I mean, we are in fact looking at scraping rooms and putting, it's like airlines, and putting chairs in where they're just a little narrower, right? So the fact that I know that in my largest classroom the chairs are currently on 36-inch boundaries, but that 26 inches is reasonably comfortable, but 21 inches, which is what our friends in the electrical and computer engineering department did, are considered problematic for persons of my size who all then sit in the class like this. The fact that I know that and I know what those chairs costs, right, is slightly terrifying. But if we could move some of our 200-person classrooms to be 300-person classrooms, then suddenly I can teach almost 1,000 people with just 3 sections, and I mean it's crazy, and it feels like a lunatic short-term Band-Aid. And I know more people in facilities and services now than I ever really wanted to know. Yes, please.
I didn't quite follow the heaviness discussion. So I don't know how many. If you take 4 classes a semester, that's 32 classes.
Yeah.
If that is 6 or 7 classes, they can do the general university requirements plus the needed math requirements, and then they take. There's enough that you can do that in 6 or 7 classes. Maybe the math doesn't quite.
Yeah. So I guess I'm not sure what the question is.
Well, I just don't understand how. If it seems like 10 classes in C, at least 10 or more in CS,
Yeah.
10 or more in X.
Yeah.
Is enough that it basically crowds out almost everything else, including like impeding on general education requirements and math.
Well, if you want to hold that thought, I'm going to actually show you one complete curriculum plan for one complete degree with like lots of little boxes with the full set of names in it. Yes, to first order, I am fully specifying the curriculum, right? It is not a highly flexible curriculum. How about that? That's an honest thing, right? I nail down a lot of computer science that my faculty has said is necessary for us to be happy to call it a computer science degree, and the X department faculty is be happy to call it an X degree. How much flexibility is left? Not a lot. Okay, I don't think it's 0, but it's not a lot. That's an honest assessment. Yeah.
So sounds like when you have a large class, you break it into sections, so you don't have somebody teaching 1,000-person class or 500. You split it into multiple sections. So
Yeah,
everybody teaches
and that's physically based. That's like a room thing. Like the biggest room on campus is several hundred, but it's almost impossible to get. There's a couple. There's like exactly 8 rooms on campus that have 300 or more seats in them.
So does the same professor teach the multiple sections, or do you have 2 professors?
It depends. If someone is teaching, say, 600, we would probably have them teach 2 sections of 300. If someone's teaching 800 or 1,000, we'll probably have 2 faculty, doing that kind of stuff. Which is why if we could increase the density of people of chairs in rooms, we could make the workload lower. It's scaling a course, standing in front of a course with 200 is not that different from standing in front of a course with 300, as long as we give you enough teaching assistants and graders and and other kind of ecosystem. You guys know this. I mean, one of the things that's new and challenging is that you have faculty teaching a course with 800 people. It's like running a small startup company. There's a staff of 30, right, involved in this. I mean, there's 10 TAs, right, and there's 10 graders, and there's a couple of administrative people. And one of the things that we started doing, which has been surprisingly successful, is we have teaching assistants, we have research assistants, we also have something called just graduate assistants. And graduate assistants are not people doing research, they're not people doing teaching, they're just doing like administrative stuff, right? So like the library hires tons of GAs from random departments across campus to help just like manage books and stuff like that. We started giving the very large classes an ecosystem of GAs. Many of them are from like departments of English and departments of history. They are delighted to get a full-scale TARA sort of appointment, have their tuition waived, and come in and manage a class of 800 who every single day has a half a dozen people saying, my dog ate my homework, right? So there's just the amount of stuff that happens in the life of a 1,000-person class that gets mitigated and filtered by a PhD level professional. That's been a spectacular success. One of the biggest problems, this is all these like surprising things, is when you are running one of these classes, just finding a room big enough to have a staff meeting for all of the people associated with your class becomes a challenge. Yes?
So we've been hiring undergraduate TAs for quite a while.
Yeah.
How about you?
We have a little bit of a challenge on that, which is that we have, many folks have unionized graduate assistants. There is, because of the union contracts, some very bright lines on what we're allowed to ask undergrads to do. And so there are some things that undergrads would actually probably be very good at that because of the, the rules, we're not allowed to let them do. So, yes?
I would be concerned. A lot of the students who come from humanities have a very different background.
Yeah.
Many of them, the reason they chose humanities or anthropology or sciences, other sciences like that, is because they didn't have a good mathematical background. So they come from a very different background, and I would be concerned about their dropout rate.
Yeah.
So I know you mentioned that you select those students, in, so they're handpicked in some sort. But nevertheless, what is your dropout rate? And what's the plan B?
At the,
What happens if they drop out?
at the moment, we don't have, I mean, look, we don't even have we don't even have 4 years of the curriculum yet, right? They are not dropping out in larger numbers. Some of them are struggling, right? Which is perhaps the sort of learning experience, right? I mean, look, to get into one of these programs, you pretty much need, a 4.0 and semi-perfect, ACTs, which means the math side of your ACTs have to look like an engineer, right? And we're very clear about like all the math courses and all this other kinds of stuff. And so yeah, we're self-selecting. And look, it's already the case that some people in CS come in and decide they don't like, they love to program, but proving stuff not so much, right? This happens too. So I mean, it's a completely legitimate concern. You're a very special person if you want to do computer science and anthropology, right? Yes.
What do you think about web-based instruction?
Hold that thought. I'm going to talk about a little bit of that stuff at the end. I'm going to talk about the MOOC stuff that we're doing, which is not in this space, but we love it. We're not doing it for this yet. Let me just look at, show a little bit about so what's it look like? This is 1-year-old data. So CS+X is approaching 30% of all CS. Right, CS+X is approaching 50% of admitted freshmen. That's because the CS math and CS stats, especially the CS stats, is becoming big, but we think that the X's are going to be growing things out. The CS+X new degrees are 28% female. That's respectable. I will note that it's just historically been the case that computer science was appalling, just appalling. And now because we are so popular, and I think because the notion that computing and data is broad and ubiquitous and has lots of sort of social touches and interesting things, it's not just people writing enterprise software or games and stuff like that. I think we've become less insular and less narrow than we used to be. So just the freshman class in engineering is 46% female. Right, so we're very close to gender parity, on this one. So the whole ecosystem is, I think, pretty positively aimed. And one of the things that's cool about this is that, yes.
Have you had a pressure at the University of Illinois to grow overall enrollment?
Sure.
So
Yeah, absolutely.
So the percentage of CS+X majors is growing despite that.
Everything, everything is growing. So we have, I think these are almost all these, the commonalities. We are the most popular unit on campus. Right? We have more applications to the CS major than any unit on campus. It's like north of 5,000. Right? We have more people applying to the Department of Computer Science than the entire College of Business. Okay, something approaching 1 of every 8 applications to the campus is to this department. Right? And you look at the next 100, 200, 500 people on the wait list, and they also all have perfect scores and nearly perfect ACTs, and nevertheless somebody has to go in and decide who gets in. So it's very much like trying to get into Harvard, right? We don't like that, but we can't scale up to 4,000 undergrads. There's a lot of pressure on engineering in general and on computer science in particular to scale up. One of the responses is to try to go wide with the CS+X stuff, because in part it's not the whole curriculum. Right, it's mostly the undergrad stuff, and the lower division stuff has been observed in a lot of the conversations I've had with the lower division faculty here. The lower division stuff is all designed to scale up. Right, so in some ways it's a reasonably intelligent middle ground accommodation to growing without having to grow every single thing we teach by a factor of 2 or 4 or 10. So the side effect is that us doing CS+X has become a very popular thing. So there are 11 more X's in flight at the moment in varying stages of realness. So these 5 X's, crop science, advertising, music, philosophy, and geoscience, have been approved by the X department and the Department of Computer Science. Geoscience is in liberal arts and sciences, philosophy is in liberal arts and sciences, music is in fine and applied arts, advertising is in media, crop science is in agriculture. We believe that those 2 we will be able to use the approvals that we got for the CS+X template in liberal arts to not have so much regulatory burden. The others are actually new degrees in new colleges. They're going to have to go all the way through. One of the things I'm super happy about is that on Monday the Faculty Senate voted for crop science. So that's a very cool one. I'm going to show you some details there. The next one out of the gate is probably music. It's the most well-designed. And the one after that is probably advertising. We are at the point now where we make people write an application for why they want to be in CS+X. Right?
Not the students, but the departments.
The departments. We make the departments. So it's like, why do you see us as a partner? What is it that you want to do? I mean, look, we just want people to be thoughtful about, like, why, and we're trying to prioritize. And one of the things I will tell you is that the tightest pitch we have ever seen was from the philosophy department, which in hindsight makes perfect sense. just makes perfect sense. And the next ones that we were talking about is curriculum and design and education, economics. This is kind of a no-brainer. My new best friend, the head of the economics department, said, Rob, you have to let us be an X. We'll start small, 300 students. Political science, actually slightly before the election, now perhaps even more so after the election. English, art and design, and a bunch of units in business. The art and design group meeting was one of the more just the more fun and high energy meetings. We went to the art school. There's not a whole lot of other reason I would have been, in the art school. My leadership team there, their leadership team there. We were the only people in the room without visible tattoos, right? I'm not kidding at all. We started talking about the fact that we both teach gigantic outward-facing service courses to persons who will never be professional computer scientists or artists, and we feel it's super important for us to be offering those things at scale to increase the sort of the intellectual diversity on campus. And the art and design folks said yes, and those courses on our side are filled with engineers. And I said, really? And they said, yeah, everybody who wants to think about product kinds of stuff, they come over here and they take one of our intro courses. So that is like one of these no-brainer kinds of things that you don't know until you start talking to people you would never otherwise meet. Yes?
I find it interesting that I don't see biology, engineering, and other STEM fields in this list.
So I will give you a couple of answers there. None of the other engineering departments have evidenced any interest in this. And I think there is a general sense that since we are a peer department in engineering, they'll just come take some of our classes. Now, the new thing is that they are now complaining that they can't get into my classes, right? But no one has come over and said, we would really like to be doing undergrad stuff. There is a bunch of interest in professional ed at the master's level, right? Joint kinds of things. Like aerospace would love to do something with us in that space, but that really not any interest in undergrad.
So I was wondering if essentially this creation of the half X, I can imagine that some departments would not be happy and would say half an X is not good enough. So I can imagine say the biologist saying half of a biology degree is no good. So do you think something like that is going on? Some people may be more flexible and some others
and here's what I'll tell you. One of my friends is someone who does kind of like atomic level simulations of molecular systems and cellular systems, and she's in the chemistry department. And we go to the same gym, and I was talking about, it's like I was talking about CS+X. We started talking about this, and 24 hours later, the head of chemistry said, I need to be an X. Right, so I didn't get any grief on that. One of the things that's true about biology that's a little bit challenging is that it is a whole bunch of departments in a school, okay? And I think that makes for some complexity. So I'm told I need to go more quickly here. So I'm just going to show you a couple examples, and then maybe we'll do a very lightweight discussion of the graduate stuff. Anybody see the movie Interstellar? Right? In a dystopian future of climate change and a basket of deplorables involving viruses and things like that, the world's food supply, goes away, and for some reason, black holes and spacecraft are involved to fix that. I'm not kidding at all. There's this interesting quote from a discussion, a line in this movie: the world doesn't need any more engineers. We didn't run out of planes and television sets. We ran out of food. Right? I would like to argue that the first line is really dumb, right? But the rest of it is actually okay. So this is the crop science degree that we approved on Monday. These are the courses that are going to be on the crop science side, and they are not all nailed down. There's some choose one of something. So, on the computer science side of the world, what do you study? Broadly, hardware, software, and theory. On the crop science side, what do you study? Bugs, weeds, and plants. There really is a course called Introduction to Weed Science. Okay? Those guys are all about data. Those are satellite images of crop stress. Those guys are going to go Uber before the rest of us do with autonomous drones and vehicles. And those guys are actually doing genomics. They actually want to do genomics on tractors. They want to do metagenomics like every square kilometer. All right? So it's a really cool degree. In response to the earlier comment, I think the resolution is not good enough, but that's what the music degree looks like. Pretty much all of the slots are locked down, right, for what the curriculum is. And it's a bunch of our classes, a bunch of ECE classes in audio, and a ton of appropriate classes in the music side. The one thing that I am actually going to probably start working on is, right now we have a one-size-fits-all CS model. We are probably going to bifurcate that curriculum. It's likely that You know, the STEM side, X degrees, they don't look that different than us. You know, astronomers and economists, they don't look that different than us. Anthropologists look different than us, right? So we're probably going to look at making some changes in some of the core stuff. I think we could probably live with 2 versions of the core. I just don't want to live with 20 versions of the core. And so the way I've been explaining this to people is, you know, if you think about sort of the full stack from like, you know, Moore's law stuff in the bottom and hardware and software and, you know, systems and people and Facebook and stuff up at the top, the CS+X STEM degrees are kind of hardware, software, and theory. That's a little simple-minded, but that's kind of what they are, right? And it's probably the case that the non-STEM degrees, they need to just float up the stack. They don't really need to take an architecture class. They should probably get a little more careful dose of software. They would probably be benefited by taking the databases class or an HCI class or something like that. So let me go maybe very, very quickly through the just the other thing that we've been doing. The other wave that's obviously happening is the data wave. You guys know a lot about this. This is my new favorite quote. Data isn't fissile material. It doesn't spontaneously reach critical mass and start producing insights. I think this is great. This is why partnerships with computer science departments in this universe are so important. And if you actually go talk to the statistics guys, you see exactly the same curves. Slightly different exponent, z minus 1, 2, or 3, right, on when the bump hit. So this is statistics enrollments, whoosh, and it's gotten really double whoosh over the last couple of years. And this is across all of liberal arts and sciences, divide the instructional units delivered by the tenure track faculty, and whoa, little tiny statistics departments are teaching at a bigger level of intensity than chemistry and math and psychology and English, right? So these guys look exactly like us. And so one of our responses, and this is the answer to the question in the back about what do you think of web-based stuff, is we're building a Master of Science degree in computer science on the Coursera platform, delivered mostly but not entirely as MOOCs, done as a partnership between computer science, statistics, and the iSchool, right? So we're doing, you know, platforms and databases and machine learning. Our stats friends are doing the foundational methods, and the iSchool folks are doing, you know, life cycle and curation and stewardship. As I jokingly say, oh crap, humans touched my data, right? Things happen. You can't ignore that stuff. And you guys are in this space, you know, we're in this space. We're a Coursera partner. You guys used to be, you're on edX now, right? Georgia Tech has master's degree on Udacity, but their next master's degree on edX, and I have no idea why CMU is not in this game. It's kind of weird. We're a very big Coursera partner. We're Coursera's 3rd largest partner. We have something almost 3 million people in our MOOCs. About 1 million of them are in my department's MOOCs. And so we are building on the experiences of our friends in the master's degree that have a MOOC going on in this space. And Coursera actually did a bunch of marketing surveys for us and said, there's just a gigantic opportunity. There's a tremendous amount of stuff going on here. So we started by building these specializations that are long sequences of short MOOCs, right, month-long, you know, kinds of sequences. So we did the cloud one, then we did the data mining one. And the way the degree is being architected is it's 32 units, which is 8 courses. We charge $600 a unit, and a course is 2 MOOCs and some stuff that you have to do for credit. So you can just go take the MOOCs, right? But for credit, you actually have to take proctored exams after each of the 2 short MOOCs, and then you have to do something like a project or something with us involving live faculty or live TAs. So this model is called Stackable Degrees, right? And the idea is go take the MOOC. Yay, you, right? Watch the MOOC. You want to use the graders and do the homework, pay $50. Great, you took a MOOC. You could take a bunch of MOOCs and maybe get a certificate that would have our name on it and Coursera's name on it and say, I have a certificate in data mining or I have a certificate in cloud. But if you want to go to the next step, you could actually say, you know, I already took those 2 MOOCs. If I apply for the master's degree at the University of Illinois and I am admitted and we actually make them apply and we actually admit people, right, then I can actually register for the class and I can engage with teaching assistants and stuff, and maybe I can get actual course credit and I can get an actual master's degree on this platform. Yeah. Right, so this degree launched last semester, right? It's absolutely brand new. This is one of those things where you're building the airplane while you're flying it, right? It's so far so good. I mean, you know, invite me back in a couple of years and ask if it, you know, how well it's going. So if you remember nothing from this talk, you will remember that I ended my talk with a diagram composed of nothing but fish, right? One of the things that you're going to do is go deep, and if you go to the deep part of the ocean on this slide, you'll see a gigantic fish that says, for your CS majors, you're going to make everything bigger. We already understand that. But another interesting opportunity is to go wide, recruit people who are not your majors into the universe, into the pond, and play with them. And the other way to go wide is to build these MOOC-based master's degree, professional degree engagements, which is another interesting way of taking the ideas and getting people who would otherwise not be in your department. And so with that, apologies for going a few minutes late, and I would be happy to take any questions. Thank you.
If you have additional questions, I'll bring the mic to you.
Well, I would like to thank you very much for your excellent presentation. I just have one more question. Do you think the BS program under CS+X would be more successful, or the MS CS+X? Thank you.
Honestly, in an ideal universe, I would be pursuing both of them. I think one of the things that's a little challenging for the master's degree is that I think the master's degrees really need to be a little more customized. So if you think about what someone doing bioengineering or biotech, think about what like a genomics or a bioinformatics CS+X would look like versus an aerospace CS+X versus an HPC, CS+X. I think you can't just say, oh, look, you're going to take these 4 classes. I think you actually have to be you have to design those degrees. The thing that's been very workable and sustainable about the CS+X stuff is it's the same set of courses, right, for everybody. But I think the opportunities of taking CS across the +X at all the levels of the degree hierarchy are really interesting. Yeah.
So, awesome. I have a question about the stackable degrees thing.
Okay.
And if I understood it correctly, part of the appeal for students is that taking the MOOCs is a low-cost, low-risk pathway, and then
Yes.
if they get into a residential master's program,
Right.
they can claim credit and shorten their campus time. We're trying to, edX has a thing called micromasters, which is the exact same schema.
Right.
Can you say anything about how, in trying to implement that,
Yeah.
did you run afoul of existing university guidelines about things that must obtain to be true in a master's degree, and how did you get people to sign off on that? Because we're trying to do this, but there's a number of regulations that
Yes.
are not compatible with this.
Yes. So we did a remarkable and idiosyncratic shortcut, which is we already had an online master's degree of computer science. And the way it was architected was you applied to the department, you were admitted to the department, the instruction was 100% synchronous. There was a camera in the back, well, broadly synchronous. There's a camera in the back of the room. It recorded the instructor, it recorded the PowerPoint or the whiteboard or whatever. We obtained proctors for exams, the deadlines were the same as the deadlines. That was already in place and had been in place for years, and so that was fine. And what we did for this was we said, we propose to add a track to this existing degree. So there's a reason this is not a Master's of Data Science. This is a Master's of Computer Science -- Data Science. This is a track through an existing degree. And by the way, we propose to use a different online platform for the delivery of this, which is Coursera and not another kind of a thing. And trust us, we'll make it work.
Okay.
Now, that was completely cheating, right? And there was a lot of pushback at the sort of campus level committee that, what do you mean you're giving this away at a lower price than the regular degree and all this other kinds of stuff? But ultimately, because our friends in the business school had already pioneered a degree in this template, we were allowed to say, you approved that one, and we've already got an online degree, why don't you let us do this one? And we managed to squeak that one by, right? And then the big thing that we've been working on is how you design this stuff, right? And that's been an interesting challenge. We are trying to scale this to be the same size as the Georgia Tech degree, which is a few thousand kind of students.
So thank you very much. Very exciting talk. I have a question about the business plan. It doesn't seem to be fair for the X departments when they don't really need to teach. Actually, they teach less, but they take 50% of the extra charge. How did you decide on this?
We needed a positive outcome on economics. And one of the things I will share, for those of you who know acronyms, the University of Illinois is not an RCM school, right? So this is responsibility or resource-centered management. We do not have transparent formulas by which we translate head counts, students, credits delivered, overhead, into resources delivered to colleges or departments.
And then the second, quick question.
So the answer is, I can't control anything about tuition flows from additional students, but there is history and precedent for the tuition surcharge to go straight back to the units. So this is the one thing where I know the macroscopic cash flow of where this stuff goes. So we put our finger on the one thing we can control and said we'll split it.
I see. And you have no intention to tweak the 10 courses model to fit certain disciplines a little bit better?
We are likely to go from having one 10-course sequence to probably having 2. So do you look like a science and tech degree? Do you not look like a science and tech degree? But for sustainability purposes, having these courses a core part of the existing computer science curriculum means we are guaranteed they'll always be there.
All right, and the last question.
So one question is, do the students express any concern about the lack of electives or choices? Or are they like, cool?
You know what? Ask me in a year. And you know why? Because we don't even have seniors yet. And so in some, this sounds, I'm not even trying to be snarky, but you know what? They're not to the end of their curriculum yet. I'm not sure they've figured out that they don't have any electives yet.
That's what you said before, right? You have a particular product, and the bet that you made is there will be some people who would be happy with that product, even though you know it's imperfect.
Yeah.
And will hopefully get better. Right?
Yeah. So.
But you were upfront about that, which I thought.
We're very straightforward about what it is and what it's not. So, really, ask me in a year. Okay.
Any community college can use like a stackable 2-year course of this to get some skill set for job kind of stuff.
So I'm not sure I heard.
Can we use any of the stackable courses for community college education for 2 years, 2-year educations?
There's been a tremendous amount of discussion about great universities like us and you building these resources and then making them available as building blocks for other universities to pick up and run with. It hasn't happened very much. And I think one of the concerns is it feels a little bit like the large 4-year university is coming into the community college and saying, you can fire a whole bunch of your faculty and use our stuff online. And that sounds a little negative, but that's kind of been the political vibe on this one. But yeah,
okay.
the resources are really good. It's certainly possible. It has not proved a very durable model for insertion in 2-year educational institutions so far.
Well, thank you so much for sharing all this with us.